Welcome to 8.4, area of a triangle. Our objectives are to find the area of a side angle side triangle and find the area of a side 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 triangle. And then at the end, we have some tie-ins of finding area back to the circle since we started our journey on the unit circle, and we're going to tie in triangles and circles together at the end. So let's start with finding the area of these triangles. We have A is 10, B is 6, and C is 10 degrees. So our area formula is 1/2 A times B sine of C. If we plug these things in, we have 1/2 times 10 times 6 times the sine of 10 degrees. Putting that in your calculator, you should get out about 5.21. So our area is 5.21 units squared, whatever our units are. Not so bad. Okay, again, our area formula is 1/2 A times C times sine of B in this case. So if we plug these things in, 1/2 times 9 times 3 times the sine of 92 degrees. Throwing that in our calculator, making sure it's in degree mode, 13.49 units squared. And one more, our formula 1/2 A times C times sine of B, 1/2 times 5 times 3 times the sine of 94 degrees is approximately 7.48. Okay, now let's find the area of each triangle. In this case, we have 3 sides, so we're going to use the side, side, side formula that we've been given. That formula being the square root of the side times, S times S minus side A times S minus side B times S minus side C, and S is 1/2 of the sum of all of our sides. So what I like to do is find S first. So in this case, S is 1/2 2 plus 10 plus 11. And that's going to give us 11.5. So we can use that in our K, which is going to give us the area. So we have the square root of 11.5 times 11.5 minus 2 times 11.5 minus 10 times 11.5 minus 11. And if we put that in our calculator, I put this, so I have a TI-84, I put this in exactly as I wrote it, with all the parentheses and everything. This is going to give us approximately 9.05. And that's the area of that triangle. So if you have a triangle and those are the lengths of the sides, this is going to be the area it takes. Maybe you have a triangle farm and you want to know how much area you have to plant your corn. Okay, so let's find S first. 1/2 of A plus B plus C. So that's 1/2 of 4 plus 8 plus 6. That's going to give us 9. Our area is the square root of S minus A, S minus B, S minus C. So we have the square root of 9 times 9 minus 4 times 9 minus 8 times 9 minus 6. That's going to give us approximately 11.62. Okay, let's do it again. S 1/2 A plus B plus C 1/2 7 plus 12 plus 12. That's going to give us 15.5. Our area is the square root of S minus A, S minus B, S minus C. So 15.5 times 15.5 minus 7 times 15.5 minus 12 times 15.5 minus 12 again. And that's going to be approximately 40.17. And once you find the area, you're done. Okay, now, like I said, I wanted to tie the areas back into our circles. So let's find the area in square inches of the segment of a circle whose radius is 2 inches, formed by a central angle of 85 degrees. Let me show you what we're even talking about. If we have a circle and we have a radius of 2, and we make an angle of 85, radius is still 2 over there, then we want to know what is this area right here. That little piece that doesn't get included in this triangle that we've made. So some of the things that stand out is we have 2 sides of a triangle. We have A is 2 and B is 2. And we also have angle C is 85. One thing that we should recall is the area of a sector, which is a piece of a circle. To find the area of a sector, since we're working in degrees, we have theta over 360 times pi r squared. So let's find the area of this whole sector carved out by the 85 degrees. And then in order to find just the segment that we're looking for, we can subtract off the area of our triangle. So our area of our sector is going to be theta over 360. So it's an 85 over 360 times pi r squared. So 2 squared. And when we multiply that out, we should get 2.967. So that's the area of the sector. I'm talking about this whole piece that's been carved out. That's the area of the sector. Now we want the area of the triangle, so we can subtract it away from the sector and just be left with that little blue piece, the segment. So the area of our triangle is 1/2 AB sine of C, which if we plug everything in, we get 1/2 2 times 2 times sine of 85. And through the calculator, we find out that is 1.992. And so, if we take our sector, 2.967, and we subtract off that triangle, 1.992, we're left with 0.975 inches squared. And that is the area of that little blue segment. One more application. A cone-shaped tent is made from a circular piece of canvas 8 feet in diameter by removing a sector with central angle 26 degrees and connecting the cut edges. What is the surface area of the tent? Okay, so imagine you have this tent. It looks like a cone. And if we look at how the tent was made, it tells us that they took a circular piece of canvas, and it has a diameter of 8 feet. And what they did was they cut out a sector of it, and it had a 26-degree angle, and they sewed these two sides together and then probably laid it on top of a pole so that way it would be a tent. So we want to find out what's the area of the fabric that makes the tent. So this part was cut. This is our tent here. The tent fabric. So the area of the sector, I would say, what's the area of the sector that's left? So if 26 degrees were taken out of it, that leaves us with 334 degrees. An area of a sector is theta over 360 times pi r squared. Filling that in, we have 334 out of 360 pi. Our radius is half of our diameter, so we're going to have 4 squared. And that would give us approximately 46.64. So the surface area of the tent is about 46.64 feet squared. And we're done. So I really enjoyed connecting our areas back to the circles that we started in because we're going to be using all of these things for the rest of the course. So it's nice to reflect and go back and see these connections being made of how is what I'm doing now reflecting what I've already learned.